Okay, we are going to fly the plane while we're building it and look at CodeHS, Programming with Karel, Unit 6, Control Structures in Ultra Karel. Going to start with 6.1, How to Indent Your Code. All right, so there's a video. We'll look at the check your understanding just to review it. Question 1, why should a programmer indent their code? Shows the structure, easier for other people to understand. All of the above. Okay, those are all reasons why you should indent your code. Also, so that CodeHS does not get mad at you. All right, so we have an example. So notice we have a lot of nested program statements here. So within the main function, we have a while loop. Within that while loop, we have an if statement. And within that if statement, we have another while loop. So the indentation helps keep track of what goes in where. Also, it helps you keep track of where your curly brackets go to make sure everything is all lined up. Okay, so if we run this one, we can see Karel do that nice little dance and pick everything up. Again, especially this section right here, the indenting helps us be able to process what's going on and what's dependent on what. All right, this code is functional, but you need to properly indent it. Okay, so we want to go in and try to fix this. So we have our main function declaration. So the first thing is while front is clear. And actually what I'm going to do with everything is tab everything over except for that last bracket, okay? Then while the front is clear, we want to put ball, move, turn left, move. All right. And then it looks like we have a turn right, perhaps. Not exactly sure. That should go there. I believe that should go there. And okay, so this is apparently still under the. Okay, and this comment shouldn't matter. Looks like your indentation's off. Ironically, the comments that they put for us are telling us it's off. Okay. So there we go. So kind of a little bit of guess and check there, but that should be our final structure. So the trick was trying to figure out if this for loop was under the while loop. It was, and we are good to go. Okay, a staircase. This program builds a staircase in any sized square world, but the indenting is all wrong. Our job is to fix it. All right. So let's take a look at our main function. We want to put a ball, and then the comments are actually helpful there. So while front is clear, move, and it looks like we want this to also be in there. Okay. I believe these are still under that initial while loop. Okay, once in place, create the step. Okay. And really, I'm just going through and tabbing over until the yellow goes away because I did not write this code. But we do have something funky. So that is the end of the main function. We do have a new function definition. So these could actually be back a level since they're describing this function. Okay. Not sure why we skipped so many lines there. Okay, so we finally cleaned all that up. So again, it's just a matter of clicking, tabbing over till it goes away. We are good to go. Alrighty, so jumping into control structures. So control structures are going to be combinations of using conditionals, using for loops, using while loops, creating functions. So we use control structures to control the flow of the program, how the commands execute. All right, which of the following below are examples of control structures? All right, all of those are control. So if statements and are loops as well. All right, yet another example to play around with. So we've got different worlds, different sizes, but we've got code that can work in all of them, which is pretty cool. So while the front is clear, then if the ball's present, take ball, then move. Then this last one, if ball's present, take ball, is in case we get to the very end and there's a ball at the last spot. All right, so really with these, I like these types of problems. You have to think logically, kind of have to make your code work for various worlds. Alrighty, so exercise 624. Write a program that has Carol run to the other side of the first row, jumping all over. Okay. So with this one, I think I did this one already. So just to kind of walk through, I think I was showing somebody in an example. So we had to create the jump hurdle function, which is just a series of commands to get over the hurdle. So turn left, move, turn right, move, turn right, move, turn left. All right. So the trick with this one is all of the worlds, if I look at all of them, they are exactly the same size world. Now there's different hurdles in different spots, but to get from beginning to end, there's 13 columns you have to go through. So the trick for this one is to do a for loop and have it run 13 times. And you just say, hey, if the front's clear, move, else jump the hurdle. And that is pretty much all there is to it. So when you run it, it works in that world, run it, works in that world, and so on. Alrighty, decorate the fence. Okay, so we have to decorate a fence in this one. So Carol's getting ready for Halloween. These are now jack-o'-lantern lights. They've been tennis balls. They've been pancakes. So we're going to help Carol by finding a wall, putting down the lights. Okay, so we don't want Carol blocking. Okay, so again, we can model that top-down design. All right, so first I'm going to put needs to move to the wall, or the fence. Sorry, it's a fence now, not a wall. So it's actually the same each time, but we can use the same command. So to do that, we're just going to say while front is clear, move. Okay. And then we can go ahead and have Carol. So in both worlds, that'll get Carol to the fence. We can go ahead and have Carol turn left. And what that should do in both worlds is get Carol. I'm going to go ahead and call main down here so you can see the method to my madness. So this should just get Carol to the fence and turned. Okay. So what we want to do now is kind of the same thing, but we're facing in this direction. And I'm not sure if I had to have a function. I'm not going to use a function here. I don't really need one. So now I'm going to say while front is clear again. So we've got a new direction. All right. And I'm going to say if, okay, and that would be the front. So if I go to my docs and things I can check for conditions, front is clear. left is blocked, right is blocked, front is blocked. Okay, so what I have to do is figure out the direction. So if that's the front, I'm going to assume this is my right. So I'm going to say if is blocked. Football. Okay, and what that should do, so I'm going to do that. And then I'm going to move. Now that should get me all the way to the very last spot. And in the two different worlds, I should then have a final just put ball outside of that. Okay, so I'm saying while the front is clear, move. That gets me to the fence. I'm going to turn left. Then while the front is clear, I'm going to check. If the right is blocked, I'm going to put a ball. Okay, otherwise I'm not going to do anything, and then I'm going to move. So it worked there, and it worked there. Okay. Alrighty, jumping into lesson 6.3, more Karel examples and testing. All right, we've got an example of moving a tennis ball stack. Alrighty, so we'll kind of test this one out. It's showing you've got to move two different stacks. So depending on the number of tennis balls, we have to take that into account. Okay. All right, I'm going to skip that video. We're going to get a climbing Karel. Again, this is an example of one that's kind of walking through, and that actually gets Karel all the way up to the top. Okay. Might be one we'll see later. We'll see. Okay. So I've done nothing yet, but just some examples. So you need to write a program that has Karel move 6 times and then put a ball. Which control structure do you need to use? Well, if I know exactly the number of times, I would do a for loop. You need to write a program that has Karel take all the tennis balls where Karel is standing, if there are any. Karel should end up with no tennis balls on that spot. All right, with this one, I would probably want to do a while loop. All right, this one you need to write a program that has Karel put down a tennis ball if the world has dimensions of 1 by 1. That is an if statement. All right, you need to write a program that has Karel move if the front is clear, but if it isn't clear, Karel will do nothing. Again, I could still use the if statement. You need to write a program that Karel will take a ball if there is a ball present. Otherwise, Karel should put down a ball. This one should be a if else. Alrighty, so got those knocked out. And looks like we have our first challenge. Come over here to assignment. So Karel starts at the bottom left corner and should move to the opposite corner of the world. He should end up facing east. You need to define and use at least one helper function. This must work in a world of any size. Don't forget to test your code. Okay. So what I may want to do here is create a function that's just called actually I'll just diagonal. And to move diagonal, Karel would need to turn left, move. Actually, let me think. I'm going to do this one a different way. I'm going to move first. I'm going to move, then turn left, then move again. Turn back right. Okay, so that will have me move, turn left, move, turn right, and I'll be facing in the same position. Okay. And I'm going to say while the front is clear, diagonal. Now, one thing I'm noticing, these worlds aren't perfectly symmetrical, so I may have a glitch I'm going to have to fix here in just a second, but we'll run it one time and see what happens. Okay, so let's get our first world and check. It worked there. Okay, so I'm crashing into a wall right here. So the issue, I think, is going to be maybe this last time I'm only going to move if front is clear. I want to move only if the front is clear. I'm going to leave the turn right. Okay, and now when I run it, reset, run, that fixed it. So that last little spot, because this one's not perfect, let me go back to this one. All right, I'm good to go. All right, so overall we moved a lot, just a few lines of code. Okay, and we have finally made it to the end here with Ultra Karel. So Ultra Karel can do a few more things. We can paint, we can add some color. So I'm going to jump into the quiz. Which of the following is the correct way to have Karel paint a red square using the paint function? Ooh, I've not looked at this in a while, but I think that is correct. Right, it is. Okay. What is a parameter? It is an input into a function. Okay. Okay, so this is just one to explore. So Karel's painting a red frame. So we have a function called paint red row. And we've got a new toy to play with. Karel can paint the spots a given color. All right. So just looking at that syntax, paint, and then color dot. Okay, so that is a library, something that's saved. All right, continue. All right, this is an example program. A little slip and slide Karel, and it works in different worlds. So again, while the color is, so we can also check a condition. So if we go to our docs, Ultra Karel conditions, random chance, color is. Okay, those are good to know. Alrighty, and this is going to be our last regular exercise before we get to the Karel challenges, which for my class I do as extra credit, but let's jump in. Alrighty, so how many different, so I just have one world. All right, so there's several different ways you can attack this. I've done it a lot of different ways, different times. So one, I could do it section by section. I could do it row by row. How many are there? There's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it is even. So I could do it 2 at the time. So I could create a function called paint rows. All right, and I am going to say for, I'm going to do let I equals 0, less than. Okay, I need to go 1, 2, 3, 4, 5, 6, 7. So that'd be 1, 2, 3, 4, 5, 6, 7. That should work. Okay, I want to and I need to, this is where, okay, I have to cut that down because I need to do an alternate. One, 2, 3, 4. Let's do it this way. All right, we want to paint move and then paint red move. All right, and let's test this out. So we're going to call paint rows, and I'm going to call main down here. So all this one should do, hopefully, is just paint the first row for us without crashing. Okay, so Karel did crash into the wall. So what I need to do here is add if front is clear. And that'll fix that. Okay, so this is why we do it iteratively. So let's reset the color at 8A. I'm not worried about that. So I've got black, red, black, red, black, red, black, red. Okay. So I'm going to make another function. I'm going to call it elevator. And for simplicity's sake, this is not going to make it the most efficient in terms of the processes, but I'm going to turn left, move, turn right, turn around, and while front is clear, move, and then after that's not the case, turn around. Okay, and that should make Karel go up and go back to the beginning. So let's call elevator and see what happens. Okay, so now I can say, okay, I want to, I guess I should say paint row would have been more efficient of a name. I'm going to fix that. Okay, paint row, paint row. Now there's going to be a pattern. Now I need to do, this is what I need. Okay, that is why. So I'm going to call this paint row A. And I'm going to copy this whole function, change this to paint row B, and I'm just going to invert my colors to red and black. Everything else should be the same. And now I'm going to paint row B. And I can call for another elevator. Reset and run. Okay, so now you can start to see it's piecing together. I've got 2, so I need to do that a total of 1, 2, 3, 4 times. So what I can do now is say 4, and because I'm nesting, I'm just going to use J. Tab that over. Okay. What that should do is paint the whole thing for me now. Reset run. Is not, oh, there we go. I'm using J here to avoid conflicts. Okay, that paints the whole thing for me. Karel crashed into a wall at the very last spot. So what I need to do at that last elevator, I'm going to do if Karel would be facing, that would be the left. I'm going to say left is clear. Now, maybe causing more harm than good, but let's see. Okay. There we go. Okay. So now I need to get Karel home. So I'm going to make one more function down here. I'm going to call it function go home. And from there, I need Karel to while front is clear, move. Okay. That'll have us facing that direction. Then we should need to turn left. We'll do another clear, move. And then that should get us down here facing down. So we could turn left 2 more times, I think. And I may have to get my turns figured out at the end, but let's give it a whirl. Okay, so up here in main, all right, I've got that for loop. After the for loop, I'm going to go home. And let's test it out. Okay, so yeah, I've had an extra turn left. All right, let's try that. There we go. Okay, so just to walk through it one more time. So our main function, all right, we are running a for loop. We're going to do it 4 times because it is a sequence of painting this pattern and then painting that pattern. We're going to repeat 4 times. We do have a if the left is clear, go up for that last one so we don't crash into a wall, and go home. So this is kind of our main function right here, but then some other functions we created with paint row A, paint row B. Then we have the elevator function. Another way you could have done this, you could have just kind of walk through the steps of painting 2 rows at the time, getting back to the start, and then just called that 4 times, and then you would have wound up right here, and you could have gone home from there. So there's a lot of different ways to do this one, but we got our green check marks. We are good to go, and we have our Karel Exercises badge. So that concludes Unit 6 in CodeHS. Hopefully that was a little fun challenge